Today we get to talk about parallelograms. There are a lot of properties for parallelograms. I'm posting, this is my notes that I make for parallelograms on the website. I will also just post a link to Math Open Reference where most of these things come from. You don't need to know necessarily all of these. Parallelograms are going to come up again next year in Algebra 2, but so just so you know, like there is a definition here for using trigonometry to find this. And not that we couldn't do that, we're actually well equipped. They actually moved that standard back into Algebra 2, so we don't have to worry about it right now. We might talk about it just because we've got the time. But anyway, without further ado, so let's just talk about what exactly a parallelogram is. A parallelogram is a four-sided plane figure with opposite sides parallel. Okay, now that little nugget of information, right, that little, oh, it's got opposite sides parallel, leads us to being able to tell everything else that we know about parallelograms. So let's go ahead and let's just start by labeling. We'll say these sides are parallel, right? Opposite sides are parallel. No big deal there, right? Okay. Now, if I were to put all the properties of a parallelogram on this one parallelogram, it would become so impossible to read. So we're going to kind of try and do these one by one. You ugly this thing up real quick. So your first thing is that the area is the base times the height. And I know you're probably thinking, well, that sounds a lot like a rectangle. Well, all these things that we're going to talk about is true for rectangles, squares, rhombuses, or rhombi, if you want to get fancy. So the base times the height for a rectangle, yeah, that is true. But remember, your base times your height is also your length times your width, because your height here is got to be a perpendicular distance, and we know that rectangles have perpendicular angles. So it's not quite the same, but it is the same rule for a rectangle. What we need to know is that our height is a vertical line that gets dropped at a 90-degree angle. So something like that, okay, from lowest point to highest point, and it makes a right angle. And why is it so simple? Because if I were to cut this triangle off over here, right, let's just think about this. If I were to cut this triangle off here, right, I had to go snipped off here, and then I plopped it over here, I would have a rectangle. It would just be the base times the height. So it's a pretty straightforward definition for area, but we'll talk very specifically about area you know, when we're done with all the shapes. Then we'll talk about all the different areas for all, okay? All right. Second rule, your opposite sides are congruent. Now, they didn't tell you that, but we do know they're congruent. We are going to hold off on that one for a second. Hold on, let's do first opposite angles are congruent, because that one we should know, okay? What you need to think of is we talked about transversals and things like that, right? If we think about this as just a big mashup of transversals, right? I've got these parallel lines here, right? And I've also got these parallel lines here. What I realized is I have like a giant thing full of nothing but transversals. Like I have transversals going this way, but I also have transversals going this way. So if you kind of turn your head sideways, we've got the same angles that just kind of occur anywhere. So I'm going to do it the same thing I did last time. So I will label them this. Okay, so we know that these are vertical angles, right? So those are the same, right? But we also know that these are corresponding angles down here, right? Which are also corresponding angles over here, and also corresponding angles over here, right? We have just four of the exact same intersection. And then we know that the other ones, these are also vertical angles, right? Right? Different symbol means different angle. Okay, and what we get is a lot like when we talked about trapezoids, where yes, these two angles are supplementary, but also if I went the other way, these two angles are supplementary also. So essentially, we know two things, that any two consecutive angles, so blue one, red one, blue one, consecutive means two in a row. I know for some reason you guys don't. I've had a lot of kids ask me what consecutive means. Any two in a row that you pick in a parallelogram will be supplementary. The opposite ones, however, will be congruent. Okay, so that's good for us, and that's going to help us prove a lot of things about this. Okay, so let's get rid of all those for a second. I'll put back the red ones and blue ones. Goodbye, 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 goodbye. Okay, Um, again, let's just keep it with, you know, the opposite angles are congruent. Okay, so now let's talk about how we know the sides are congruent. Well, we know the angles are congruent. We know that because they were transversals to vertical angles. All you really need to do, and I know we're dreading that what I'm about to say, we're going to go ahead and we're going to use our triangle proof theorems. Now, I know everybody hates triangle proofs, and I avoid, if you guys watch some of my videos, I avoid writing out formal proofs because they scare people and it just turns people off from doing any type of work that has to do with this. You do have to know the basic kind of like angle, side, angle, side, angle, side, angle, angle, side, 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 and hypotenuse length. Because if you know those things, then all of this stuff will make sense, even if you're not writing a formal proof. So you still need to know the rules, even if not. So I'm going to erase these guys for a second, okay? We know that they're congruent, but I'm going to draw a diagonal. So I'm going to draw this diagonal here, right? Well, if I go ahead and I label out some I'm going to call this parallelogram A, B, C, D. Now, if I can prove the triangle A, B, C is congruent to triangle C, D, A, right? A, B, C, this one up here, and C, D, A, this one down here. If I can prove that those two are congruent, then I know that the opposite sides are going to be congruent as well. Well, we have an angle, right? We have the angle there, right? And in fact, it's not too bad for us to find a second angle because my diagonal is also a transversal, right? So I have a set of parallel lines here, and I also have this transversal that cuts across, which means that these are alternate interior angles, right? And if you kind of turn your head sideways a little bit, we could go a step further and say, hey, here's a parallel line, here's a parallel line, a different symbol. These are also these are also alternate interior angles. Can I turn your head sideways, 90 degrees to the left, 90 degrees counterclockwise, okay? And of course, these two triangles also have a common side, right? They have AC as a common side. So I can go angle, side, angle. I could go angle, angle, side this way. I can go angle, angle, side this way. So the big thing that we know is that once these are true, they become increasingly easier and easier and easier to prove, but that's a pretty straightforward thing, and therefore we can say if those two triangles are congruent, then all their parts are congruent. So we're going to go ahead and we can definitively say that in any parallelogram, your opposite sides are also congruent. So this will be the same as this one, and this one will be the same as this one. All right? Diagonals are congruent. So opposite angles are congruent. Consecutive angles supplementary. Diagonals bisect each other. So again, I have to clear a bunch of stuff off of here in order for this to work. Hold on. Okay. My diagonals are bisecting each other. Okay. So first of all, your diagonals are not congruent to each other. We'll talk about them when we talk about rectangles. That will be true. Here, clearly, if you kind of think about this, kind of stretched out, this one right here is much longer than this one, right? It's kind of stretched out. I'm using my hands even though you can't see them. They're stretched out, you know, kind of this way and squished in this way. So the big thing is to keep that in mind. Now, again, let's talk about some things we know. Well, we know the opposite sides are congruent, right? We proved that already. That was very nice of us, right? So we know that this side is the same as this side, right? I know this side is the same as this side, right? And then we have all of these, right? This one, alternate interior with this one, right? And this one, alternate interior with this one, right? So we had all these different things we can say, and these were vertical angles right here, right? Right? So again, let's go ahead and we'll label some points. I've got A, B, C, D, and I'm going to label this point in the middle here E. Well, let's think. Triangle A, B, E is congruent to triangle C, D, E, right? Because look, I've got angle, side, angle, and over here I've got angle, side, angle. So we know that these two triangles are congruent. I'm going to do them in different colors because otherwise this gets really complicated. But what does that tell us? Well, if they're corresponding, then this one is the same as this one, and this one is the same as this one. Again, I know I put two stripes there, but I'm putting a different color because I'm going to run out of symbols. But essentially what you know is that I have two congruent triangles here, right? But also we kind of look the other way. These two triangles are congruent as well, okay? So again, your diagonals are going to bisect each other. They're not both congruent to each other, but AE is congruent to EC, and we'll go DE is congruent to EB. All right. Diagonals, congruent angles, we said that right, as alternate angles, diagonals bisect each other. That should be enough to get you guys started. You're going to have to solve some problems. If you want to hold off on the problems till tomorrow, I'm going to go over specifically how to do a lot of the problems in Excel, so I'm going to add the suggested skill, but if you guys want to wait for tomorrow to do the work, that's fine. I don't expect it done until early next week. I do want to talk, I'll talk real quick about what a rhombus is, even though it's not. So a rhombus, which I have to draw differently, so I don't know why I did that. A rhombus is a type of parallelogram. I think with a rhombus, and I'm so bad at drawing rhombuses. That I think, okay. That is shit, okay. The one extra thing you have to remember about a rhombus is that not only do you have all those things true, you have one extra nugget of information, is that I'm sorry, two extra nuggets of information. That's that all your sides are the same length, and as a result of that, you'll find out that we have right angles in the middle. So I'll probably do a specific class just on rhombuses. This is normally where I would tell you they're going to ask you all about your regions, but hey, we don't have to worry about that. So anyway, like I said, I would really like to see you guys exploring this Math Open Reference website. So I'll just show you real quick like what some of them are. So if I said opposite angles are congruent, and I go to that, what it'll show you is it will show you as you change one angle and as it keeps the sides parallel, kind of what would happen. So there's a little animation like this for all of them. Math Open Reference specifically for geometry is a great tool, and it will give you all sorts of different things on here. So I'll leave that up there. Please explore that today. I'll put the Excel skill if you want to try that. You can try that as well, but I really think tomorrow might be a better idea. Okay? Thank you, guys.